So with all that, that brings to my summary and outlook. So in summary, I hope that you can just bring home the bring home message that I want to deliver is just two things. One is basically advanced in fab technology, material understanding, and device design. They are key ingredient for the CMOS scaling. And with those technology developed, CMOS technology can be leveraged for quantum computing on many aspects. Now that's the outlook. And I want to echo to the beginning. Let's march backward into the future. If we really look into the first computer of ENIAC and compare of the first chip that demonstrates quantum advantage, then we can actually see many similarities, basically cables connecting those things together. But however, the real blossom has been brought by the semiconductor or the solid-state transistor. But to make this really upscaling possible is actually the invention 10 years later on the integrated circuit. The integrated circuit crucially solves three problems: the integration, the isolation, and also connection. Integration means that you can allow connection multi-electron devices together and also to help them perform in a very reliable way. That is solved by the introduction of the planar process. Second is isolation, because you need to electrically isolate different components. This is solved by the introduction of the p-n junction isolation. Essentially, you separate them away by the depletion region, the p-n junction. So finally, is the connection. So you need to have electrical connection between different components, and this is solved by the introduction of the metallization layer. Quantum computing nowadays are actually facing similar problems. For the integration part, how can we have good qubit yield over a multi-qubit chip? And can we also incorporate the control circuit together? The isolation is a big limiting factor because the crosstalk between the qubits can be large, that can also limit the overall performance. And finally, is the connection, which can be a big problem for silicon spin qubits. Why? Because the qubits are so tiny. How can you solve the qubit connection and wiring fan-out problem if you want to make 2D array? So hopefully, with this cooperation and then the cooperation between industry and academic research labs, we can really bring the quantum integrated circuit into the real life. And with all that, I would thank you for your attention again.